Okay, friends, so in this video, we're going to talk about dividing rational expressions. And I think the easiest way to do that is to just do a quick review of what do you do with fractions. So if I have this really general fraction, a over b divided by c over d, can you remember how you would actually set up the division for this? Well, hopefully you would tell me that you would flip the second fraction and then multiply, or a lot of people also say that you could multiply by the reciprocal of the second fraction. So what I mean is, if I go back to this problem, a over b divided by c over d, so notice what happens. I always say flip, but really it's multiply by the reciprocal. So here's my setup. And now this is just multiplication, and we've talked about multiplication in other videos, so now you can just multiply straight across. Okay, so from here, this is really all we need to know then for working with rational expressions, because it's really the same thing. So here's maybe a baby rational expression we could start with. So I've got 5x over 9 divided by 2 over 7x to the fourth. Okay, so the first thing that I'm going to do is I'm going to set this up so that I've got this multiplying by 7x to the fourth over 2. And then I can just multiply straight across. So 5 times 7 is 35. I add the exponents, so this will become x to the fifth. And then in the bottom, this will be 18. Okay, and I actually like this problem because I think it also brings up a really common question with division. Maybe when you looked at this, you first thought, oh, I should cancel out these x's. And so that brings us to a great segue of when can you actually cancel when you're working with division. So you can cancel only after you have set up the multiplication problem. So when it's still in its division form, you cannot cancel yet. So you've got to wait for that. Okay, so I feel like I've kind of set this up for you, and I think what would be good now is just to check your own understanding. So I have this problem here, 12x to the 7th over 45 divided by 42x to the 3rd over 15. Okay, so I think we should just check your understanding. Pause here, give it a try. Remember, math is not a spectator sport. Pause, hit play when you're ready. Okay, so I am going to first set up the multiplication problem. So now this becomes 15 over 42x cubed. And so now that I've set up my multiplication, now I can make my cancellations. So let's see, what can I actually cancel? Well, I noticed that with the 45 and the 15, so actually I can divide both of these by 15. So I'm going to divide the top and bottom by 15. And then for 12 and 42, so let me think. I think that 6 is the largest number. Am I thinking of that right? I hope I'm right. Okay, so I talked about in my multiplication video, I don't like to do too much too fast. So I'm just going to simplify the number parts of this and see where I'm at. So let's see. This is going to become 2x to the 7th. This will be over 3. This will be just 1. And then this will be 7x cubed. Okay, and so now that I have everything written out, I can see that I've properly canceled out the number part. And then the other part of this is I can still work with the exponents. So I have more x's on top than on bottom. So I'm going to subtract 3 from this x here, and I'm going to cancel out this x. So now I can multiply everything together. This becomes 2x to the 4th over 21. So we're good to go. Okay, cool. So now, why don't we talk about this next example? So now I've got more polynomials, more fun. So what am I going to do with this particular polynomial? Because it's not a fraction, right? So I actually think that this is a great moment for you just to check kind of your understanding. See if you can finish it. Worst that happens is that you don't. And hit play when you think you're ready or when you're stuck. Okay, so we can first of all think of this as a fraction over 1. We can just make that 1. It's always kind of assumed. And so then I can go ahead and rewrite this. So I've got x squared plus 4x plus 4 over x plus 5. And now I'm going to rewrite this as 1 over x plus 2 to the 5th. Okay, So next I need to factor. So I'm going to factor this. So this will become, so this is x plus 2 times x plus 2. So you have two options on how to write that. You can just leave this as x plus 2 times x plus 2, or, and this is how I'm going to do it, I'm going to write this as x plus 2 squared, because that will allow me then to cancel with this exponent here, right? And now in this particular case, where do I have more x plus 2s, on top or on bottom? I have more on bottom. So when I actually make my cancellations, this will cancel out, and I'll just subtract 2 from the exponent here. And so now I just have 1 on top, and this will be x plus 5 times x plus 2 cubed. And so there you go. So, and we'll just leave it like that. Okay, cool. So let's just try one more. So this one has maybe just slightly more challenging factoring. So what I want to do is I want to encourage you to try this one totally on your own. So hit pause here, do your best, and when you think you've got it, hit play when you're ready. Okay, so I am going to first set up my multiplication. I don't want to do too much too fast. Okay, so now I need to factor things. So this is going to factor x plus 1, x squared minus x plus 1. And then here it looks like I can factor out 6x. So this becomes x squared minus x plus 1. And then let's see, this will be 8. This will be x plus 1, x minus 1. Okay, so now there's a whole bunch of things I can cancel. So in this case, these are going to cancel out. And these x plus 1s are going to cancel out. And then also, I've got the 6 and the 8, so those are both divisible by 2. So I'm just going to note that. Okay, so then on top, let's see, I'll write this as 4, and then this is going to be 3x, and then x minus 1, and everything else canceled out. So that would be the final answer in this case. So that's the idea then behind division. And if you feel like you want to see any more of these types of examples, or you'd like more instruction, maybe at like a slightly slower pace, I do have more videos on this. So this is just kind of to give you the gist of the idea, and then you can make this work for whatever your needs are. But I do want to say there is one other way that we can set up division. So I want to just show you that in this video. So I've got this problem, 5x plus 5y over 24, all of that over 15x squared plus 15xy over 12. Okay, so this is kind of two things actually. So this is a fraction, this is another fraction bar, right? And then a fraction. This is a fraction over a fraction, all within a fraction. So all the fractions. So in one way, we can view this as a fraction. In fact, when a fraction is set up like this, where we have a fraction over another fraction, all within a fraction, it's called a complex fraction, which is probably a good name for it, right? But the other way that we could view this is we could also view this particular type of problem as a division problem. Because the interesting thing about fractions is that, so let's see, let's say that I have for a second, what if I had like 4 over 2? So forget about what we were talking about. Let's just think about this in general. So your brain will actually automatically view this as a division problem without you even realizing it. So we could view this as the fraction 4 over 2, but instinctively we know that this is also 4 divided by 2, so this just equals 2. So what this fractional bar means is it can mean fraction or it can mean divide. So in this giant context, what I'm going to do is I'm going to take this part of the problem and I'm going to set that up as division. So I'll get rid of all this stuff that I was just looking at. And so I can set up this division problem as 5x plus 5y over 24 divided by 15x squared plus 15xy over 12. And now that I've written this out like that, it's like, oh, okay, this is obvious what we need to do. So then I can just set up the multiplication problem. And then from there, I can go ahead and start making my cancellations. So let's go ahead and do that. So I've set up my multiplication problem. And so now what else can I do? Well, I can divide the top and bottom here by 12. And then there's some factoring that I can do. So I can factor out 5. Let's see, this becomes 2. This is a 1. And then let's see, what does this become? This becomes 15x. And then this is still x plus y. And then I can see some other cancellations that I can make. So there's a whole bunch I can do actually. So these x plus y's drop out. And then I can divide now these parts by 5. So in the end, let's see, it looks like I'm going to be left with just 1 on top. Everything else canceled out on top. And so then this is going to leave me with 2 times 3x. Yeah, just 2 times 3x. So this becomes 1 over 6x. So this looked like really complicated, right? And then it simplified to something so simple. So, and that's something that can happen, right? It's just a case-by-case basis. Okay, so we've got one more example here. So I want to encourage you to try this one totally on your own. Pause the video, hit play when you think you've got it. Math is not a spectator sport, and then we'll get the party started. Okay, so first let me just set up the division problem. And so I just straight up divide this part here. And then I'm going to flip this part, so I'll just show you what that looks like. Okay, and so now I can go ahead and start canceling things out and factoring and all that good stuff. So let's see, this one is a difference of squares problem. So this is going to factor 4x minus 5 and then 4x plus 5. And you know what, I'm actually, before I go any farther, I'm going to cancel out this x to the 5th. So I'll go ahead and just subtract 5 from here. Okay, so this x to the 5th now will go away and just be a 1. We'll just leave a 1 as a placeholder for right now. And now this will be 9x squared. And then here I can factor out a 9. So this will become 4x minus 5. Cool. And so now we've got some more things we can cancel out. These 9s will cancel out. This 4x minus 5 will cancel out. And so now, actually, if you notice, so everything in the denominator has canceled out. So technically what I'm left with now is 4x plus 5 times x squared over 1, but you don't need the 1, so you can just rewrite this as so. And if you want to distribute the x squared in, that's totally fine. But yeah, so you don't need the 1 here. Okay, and so that brings us to the end of this video. If you're looking for more instruction, I actually have some other videos on this that go at like a little bit of a slower pace with even more examples, or if you just want to see more examples, I've got a video of that too. So I'll drop some links to those in the end screen of this. And yeah, so check out my library if you're looking for more. If you found this helpful, consider hitting the like button or subscribing to the channel, and I will talk to you guys next time. Thanks for watching. Peace.